1 liter, and I'm going to make the math incredibly easy. I need 1 liter of a 1.00 molar solution of sodium chloride. Okay, now, why in a real lab do you work like this? Okay, because I have 30 students, I reasoned through to have enough solution for all 30 students, or 15 pairs of you, it's going to take about a liter. So let's go make a liter of it. And for the experiment we're going to do, it should be 1.00 molar. Okay, now, notice one thing I just said. I said molar, and that's not a word over here, because chemists have so many different ways we speak. I can say molarity. I can use a capital M, and it means the same thing. Or, there's a third way, and this is usually the way that trips people up. I can use the first 2 syllables as an adjective. And I can say, I need a 1.00 molar solution. Okay, so mole, okay, molarity, the whole word, M, or molar. So don't let that confuse you. So if I need this, okay, the way you would do it, since I need a total of 1 liter of solution, I'd use a volumetric flask. This volumetric flask, if you have an eagle eye, you can see a little line that's etched up on the neck. When this thing is full, so that the bottom of the meniscus is right on this line, you've got 1 liter exactly. Now, it's really well calibrated. The problem is, if I needed 2 liters today, either we got to buy a bigger flask, or he's got to make the stuff up twice. If you don't want 1 liter, this is useless. If you needed 500 milliliters, and you couldn't afford a whole liter, this is useless. So you got to buy a whole series of these things. So we would take a flask like this. Okay, and I see that is my big clue. And a lot of times, we abbreviate this definition like this. However, if you do abbreviate it, you got to remember, moles of what? The solute. Liters of what? The solution, not the solvent. The solvent, once again, is never mentioned. So, what do we need? Okay, it means that I want this to be 1 molar, and I need 1 liter which means I need 1 mole of sodium chloride. Okay, now, if I need a mole of sodium chloride, chapter 2, this will haunt you forever. Let's pretend we're working compounds only. I got grams and I want to get to moles. We know we relate back and forth with the formula of weight. If I'm going this direction, what's my math operation here? Divide. Or if I want to go backwards, we multiply. Okay, I don't have a balance in the lab, neither does Ruby that measures a mole of anything. It's in grams. How many grams of sodium chloride do I have to take? Anybody got the number?
59.
Okay, or if we stick with 3 sig figs,
58.5.
58.5 grams per mole for sodium chloride. Nita, tell us how you got that.
Oh, I got the formula weight.
Yeah, but I mean, how'd you do it?
Oh. How'd I do it?
Yeah, how'd
The
you do it?
formula weight?
Yeah, okay. I mean, so you think that's
23
so easy.
sodium, and then 35.5 chloride.
Exactly. A sodium at 23.0, a chloride at 35.0. And why I'm saying that, emphasizing, because if you go back this afternoon or tonight, as you should, go through your notes, you will see 58.5, and you'll go, where the hell did that come from? Or something similar. Okay? So, it's formula weights. When you see these random numbers on your papers, almost invariably, it's a formula weight that somebody provided in class. And we need that 58.5. So what I would do, okay, I would put into my volumetric, this is the modern art for this, I would put in 58.5 grams grams of sodium chloride in there. And then we would put water in. I would never ever measure the water. I would just keep adding water until we got to the line. If you go past the line, this turns into trash, and you dump it out, and you start over. So when you start up the neck, because it's very narrow, you want to be very conservative, not to overshoot the line. Now, in reality, we don't do it quite like that. What we do, generally, we're real conservative, and we put some distilled water, maybe halfway up here, put some water in, then we shovel the salt in, and then we stand and we stir, either the old-fashioned way or with a magnetic stir that does the work for you. And then you top it off with water. Because if you just start dumping water in before it has a chance to all dissolve, that you may run past the line when it dissolves, because sometimes with the dissolving process it shrinks or expands. So you want to be conservative. So a little water, then put your salt, stir it a whole bunch, top it off with distilled water. Okay, now the real problems. Yeah.
The grams didn't really matter in the problem, it was just the grams that mattered in the demonstration.
Okay, because your problem is, for Reuben, go make me up 1 liter of a 1 molar solution of sodium chloride. Now, how's he going to do that?
So we needed to find the number of moles. You just converted to grams just for the demonstration.
Yeah,
Okay.
yeah, exactly.
I'll just make sure.
Okay, let's take a look at a problem in the book, because they're going to be a little bit harder than that. So this is going to be 318. Emily, read what it says in the book. For 318.
Calculate the molarity of a solution that contains 3.65 grams of HCl and 2.00 liters of solution.
Okay, word for word. So this is 1 ton where I typed everything that was in the textbook. Okay, so we look at that. And we look for the big clue. There's only one big clue. Capital M. As soon as you see the capital M, then write your equation. And this equation has 1, 2, 3 variables. Somewhere in the problem, they got to give you 2 out of 3. Okay, so let's see what they have here. Okay, this one is reasonably straightforward. They want the molarity. Okay, now, it's very, very common. They're going to give you bad units. They're not giving you grams of this stuff, and we assume this HCl is our solute, because it's what's mentioned, and we assume water is the solvent, even though it's not mentioned. And they did give us good units here, but much more typical. For the solute, they give you grams, and for the solution, they give you milliliters. And you've got to remember, the definition, the basic definition, it's liters. So we got a nice gift there. We just put in 2.00 for our liters. Okay, but we're going to be doing this a whole bunch. Okay, so for this one, we got to do a little problem out to the side. So what am I going to need to go from 3.65 grams to get that into moles? What do we need? Allison, what do I need?
The formula weight?
Formula weight. Do you have it?
Yes, 36.5 grams per mole.
Okay. 36.5 grams per mole. And so out to the side, see, this is how many grams, and it just happens to be similar to this, just to make the math easy on our brains. And so we got this many grams, we are here, we got to go there, and so grams and grams cancel, moles come around on the top. So Allison, got a number for me? Okay, how about SIGs there? Should I just take 0.1?
1, 0.
0. Okay, now we got our 3. Never lose 6 as you go through. Keep at least the 3 that are there. And then we're going to divide that out. Nicole, what did you get? 0.05. 0.05. Good. Okay, so the way we would speak, the molarity of this solution is 0.0500. Or I can say it's 0.0500, capital M there. Or more likely, people will say, oh, it's a 0.0500 molar solution, where you use the first two syllables. Okay, are we all right on this one? Okay, let's take our next one.
And then